So in this example, we are going to determine z-scores. A z-score is simply a standardized distance along our number line that an observation lies from the mean. If the z-score is positive, then that observation is above the mean, and consequently a z-score that is negative lies below the mean. Now for a standardized normal distribution, the origin at 0 is the mean. So I'm just going to put in 0 right here for the mean. And then we count up one standard deviation going to the right, 1, 2, and then 3, and then count down one standard deviation going to the left on our number line. -2 and -3. So now we have this same scenario that we've seen before in other examples about the Ford Edge. It says the gas mileage for the 2020 3.5 liter V6 Ford Edge with front-wheel drive forms a approximately normal distribution, and here's our distribution again, our normal distribution, with an average of 24 miles per gallon and a standard deviation of 2.3 miles per gallon. So I'm just going to put in our average here, that's mu. That's 24 miles per gallon. And then we have a standard deviation sigma. That's 2.3 miles per gallon. So I'm just going to go ahead and put that in because I want this distribution to describe our scenario here. So again, here is our mean, 24 miles to the gallon. And then of course we just tag on one standard deviation of 2.3 miles per gallon for each increment up and take away 2.3 for each increment down from the mean. So here we have 26.3, 28.6, and 30.9. For here, 21.7, 19.4, and then of course 17.1. Now it says determine the z-score for the following miles per gallon for the Ford Edge. So that's what we're going to be determining, the z-score. And again, that's just a standardized distance that a particular observation lies from the mean. So you could see here for letter A, it says x is equal to 18 miles per gallon. And notice that it's labeled as x. Don't forget this is a number line, or more distinctly, it is an x-axis. So an x is equal to 18 miles per gallon. So visually on our number line, and this is just a visual context, if this is 19.4 right here, and this is 17.1 right here, 18 miles per gallon is somewhere in between here, right? So I'm just going to go ahead and eyeball it, and I'm just going to say it comes in probably right about there. So what I want to know is how far that distance is in standardized form. It is from the mean. So I could see that it's somewhere between 1, 2, it's somewhere between 2 and 3 standard deviations below the average here. So we could find that out specifically. And all we have to do, it's not that difficult, all we have to do is figure out how far 18 miles per gallon is from 24 miles per gallon, the average. So I'm just going to do that. So here's A. 18 minus 24. Well, that's -6. But I know that it's not -6. So what I have to do is I have to introduce the standard deviation. It does play a role. So I'm just going to divide this by the standard deviation. 2.3, and of course, 2.3. So -6 divided by 2.3, that's approximately, and we're going to go with 4 decimals, 2.6087. 4 decimals is a nice number to deal with. So it's approximately 2.6087, since it's negative, below the average. And that looks like it's about 2.6087 below the average. We're going to use the same approach for letter B. X is equal to 30 miles per gallon. Well, visually, we just kind of eyeball it, just take a practical sense. Here's 28.6, here's 30.9. So 30 miles per gallon is probably right around here. So it's somewhere between 2 and 3 standard deviations above the mean. So we'll do that. Again, we'll just find out what it is. We'll just take 30 minus 24, and that's positive 6. Of course, I know that it's not 6 because I have to include my standard deviation. So I divide by 2.3. So 6 divided by 2.3, that's approximately 2.6087. Again, we'll use 4 decimals. And we knew that it was between 2 and 3. In a practical sense, just eyeballing it, that looks like about 2.6087. C says x is equal to 20 miles per gallon. Well, here's 21.7. And here's 19.4. So I'm going to say it's probably right around here. And again, we just kind of eyeball it. What this does is when we have this distribution here graphically, it kind of gives us a sense of what's going on before we do everything mathematically. So now I can kind of see what's occurring. I want to know where 20 miles per gallon is in relationship to 24 miles per gallon. You should know that 20 miles per gallon is less than 24, so you should know that it's going to sit to the left. We just want to know how far to the left. That's what the z-score tells us. So for C, we'll take our 20 minus our 24, and of course that's negative 4. We then divide by the standard deviation, 2.3. So that has a z-score of negative 1.7391. And there it is. We know that it's between negative 1 and negative 2. And there we go. And finally, for letter D here, where x is 26.5 miles per gallon, here's 26.3. So 26.5 is probably just a little more than 1 standard deviation above. So then we go ahead and we'll calculate it. 26.5 minus the 24. That's 2.5. We divide by the 2.3. And that has a z-score of 1.087. And it looks like it's just a little bit more than 1, of course. That shows it right there. And there we go.